Let's see what we can do about simplifying to this. Maybe we can combine some terms together, but not right now, right? These are 4 of these things, 4 square roots of 8. Then I'm going to subtract 3 of these different things. These are square roots of 8. These are square roots of 18. They're different. And then these are different too. These are square roots of 32. It's like I've got 4x's minus 3y's plus 5z's. We've got 3 different things. Let's see if we can simplify each one of these radicals and see if anything turns out to be similar. So let's start here. That 8. That square root of 8. Now I can break an 8 down into 2 numbers, one of which I know the square root. Right? We can break an 8 into 4 times 2. So let's do that. Let's write this as 4 times 2 minus 3 times. Now 18. Can you break 18 down into 2 numbers, one number that you know the square root of? Well, 6 and 3 doesn't help, but 9 and 2, I know the square root of 9, so I'm going to break this down into 9 and 2 plus 5 times. Now what about that 32? Do you know 2 numbers that you can break it down into something times something, and one of those somethings is a square root, or you know the square root of? Well, how about, 4 and 8? 4 would work, I know the square root of 4, but I can do even better. 16 and 2, right? 16 and 2 is a 32, and I know the square root of 16. So I'm going to write this as 16 times 2. And now let's break each one apart. I can break apart, break apart, break apart. So this is going to be 4 times the square root of 4, square root of 2, minus 3, break these apart, square root of 9, square root of 2, plus 5, break these apart, square root of 16, square roots of 2. I know that square root, I know that square root, and I know that square root. So let's take them. We'll get 4 times. Now, the square root of that 4 is a 2, and then we still have that square root of 2. Minus 3 times square root of 9 is 3, and we still have that square root of 2, plus 5 times, and the square root of that 16 is a 4, and we still have that square root of 2. Making some progress here. Now here, the 4 and the 2 are outside, so we can combine those. 4 times 2 is an 8 square roots of 2, minus 3 times 3 is 9 square roots of 2. And then we're going to add 20 square roots of 2. So look what we're doing. We've got 8 of these, then we're going to subtract 9 of those, and then we're going to add 20 of them. Right? So let's just do them 2 at a time. So if we take these 2 here, we got 8 of them, subtract 9 of them, now we're down 1, right? 8 minus 9 is negative 1. So now we're at negative 1 square root of 2, and then we still have that 20 square root of 2. So negative 1 of these, and then you add 20, so we're up 19. So this is going to be 19 square roots of 2. So it turns out then that if you have 4 square roots of 8, you subtract 3 square roots of 18, and then you add 5 square roots of 32, what you really have are 19 square roots of 2. Now let's do the same thing in 16 as we did in 15. We're going to try to combine these 2 terms, but we can't do it directly because, first of all, I got 3 of these things here, and then we're going to subtract 2 of these things. Well, this thing here is different than this thing, so they're unlike terms, so we can't combine them. But maybe if we simplify them, we can, like we did back here in 15. Let's try it. Now, first of all, over here, we've got 3x, and then the cube root of, notice these exponents are smaller than the index. So this thing here is simplified, so let's just rewrite that one. We'll get 3x, and then the cube root of xy squared, right? We can't do anything more to this because the exponents are smaller than the index. So this is simplified already. But then we've got minus 2 times. Now let's see what we have here. Let's look at this. Well, first of all, the cube root of 8, we know the cube root of 8. The cube root of 8 is 2, so we can take a 2 out. So we can write this as times 2, and then here's what's left. I'm just going to do this in little steps here. If I take the cube root of 8, I get, right, take the cube root of 8, we get that 2. And then here's what's left. The cube root of x to the 4th y squared. Well, this is not simplified yet, right? Look at this exponent. This exponent is bigger than the index, so we can take something out. And the way we do that is, I'm going to write it like this. So for the x's, we'll take the index into the exponent. So we'll take 3 into 4. Now 3 into 4 will go once with remainder 1, right? 3 into 4 is once, and there's 1 left over. So we can take 1x out, but 1 remains under the radical. So let's do that here. So I'm going to rewrite this whole step here. This will be 3x cube root of xy squared minus, now 2 times 2 I can write that as 4, but I'm going to take that x out, right? When I divide index into exponent, 3 into 4 will go once, so I can take 1x out, and then 1x remains. But what's also there is that y squared, right? So 1x remains, but we also have that y squared. So we're going to have here, we're going to have the cube root of, right? I took 1x out, and 1 remains, and then I also have the y squared. And now look what we've got. We've got 3x, well, we've got 3 of these. And over here, we're going to subtract 4 of, those are the same things, right? Do you see it here? I'll try to circle it. This thing here is the same as this thing here. So we start with 3 of them, then we subtract 4 of them. So 3 minus 4 is negative 1. So we're going to have negative 1 of those x cube roots of xy squared, and we really don't need the negative 1, so how about just negative x times the cube root of xy squared. Moving on here to number 17, we've got this complex number minus this complex number, and we treat these complex numbers just as if they were binomials. So I've got just two-term expression minus a two-term expression. Let's get rid of the parentheses and then combine like terms. So here's a parentheses preceded by no sign at all, so we can just remove that. So we're going to get here, we will get 9 minus 4i. And now remove this set is preceded by a minus sign, so I'm going to distribute that through. So I'll get minus 7 plus 5i, right? Minus the minus is the positive. And then we've got 9 minus 7. That'll give us a 2. And then we've got negative 4i plus 5i. Well, negative 4i's plus 5i is just a 1i, or just an I. There we go. So if we take this complex number, subtract this complex number, we get this complex number.